Hi, my name's Kelly Rule from Sandia National Laboratories, and today I'm going to lead a section of the WEC-Sim training course. This section of the WEC-Sim training course will discuss how to run WEC-Sim in batch runs using both MCR and PCT. WEC-Sim MCR, or WEC-Sim multiple condition runs, allows users to run multiple cases using the WEC-Sim MCR command in the MATLAB command window. The WEC-Sim executable is located in the source directory, so that's located in WEC-Sim path/source, as you can see in the screenshot on the right-hand side. And we have examples of how to use the MCR feature in the applications repository using the link provided. Additionally, we also have online documentation for how to use MCR using the link provided. To use WEC-Sim MCR, you first need to define multiple WEC-Sim cases to run, often with different input conditions. You then type WEC-Sim MCR in the command window, and WEC-Sim MCR executes the WEC-Sim command in series for each case. Once the WEC-Sim command is executed for all the cases, a user-defined post-processing script called user-defined functions MCR is executed after each case. Then the batch run is complete. Examples of using WEC-Sim MCR are provided on the applications repository. There are three ways to run WEC-Sim MCR. The first is to specify a range of C states in using PTO damping coefficients in the input file. The second is to use an Excel XLS file that contains a set of wave statistic data. The last is to use a matlab.mat file that specifies the desired input conditions. The way MCR works is by creating an MCR structure that includes all the information that's needed to automatically run the desired MCR cases. The MCR structure includes both MCR.header, which gives the names of the parameters and functions that are being modified, and MCR.cases that gives the values or options for each of the parameters and functions. On the left-hand side, you see a screenshot of the MCR structure. Then in the middle of MCR.header, which shows examples of modifying waves.height, period, damping, and stiffness. And on the right-hand side, you see MCR.cases, which shows the values for modifying height, period, damping, and stiffness. WEC-Sim MCR then executes the WEC-Sim command for each case defined in the MCR structure. So you can see in this code snippet below, the WEC-Sim command is executed, then it checks for the existence of a WEC-Sim user-defined functions MCR file, executes that file, and continues to loop through every single instance of the MCR cases. In this instance, WEC-Sim will overwrite the parameters defined in the input file using the values in WEC-Sim MCR structure. So even if you have values defined in the input file, they will be overwritten. Using the WEC-Sim MCR command executes multiple condition run option, and it can be initiated in three different ways. Option 1 is to specify a range of C states and PTO damping coefficients in the WEC-Sim input file. So this is done directly in the input file. Option 2 is by specifying an Excel XLS file that contains the set of wave statistical data that you want to run within WEC-Sim. Option 3 provides an MCR case in a .mat file that specifies the file names in the WEC-Sim input file that will be modified. A note on option 3 is this option allows for any input variable to be altered within the MCR cases, such as wave spectrum, mooring setup, PTO components, etc. Options 1 and 2 do not allow for this. As mentioned before, WEC-Sim MCR option 1 allows users to specify a range of C states and PTO damping coefficients in the WEC-Sim input file. For example, this input file modifies waves.height for a range of 1.5 to 2.5 meter wave heights in an interval of 1 meter, and for wave periods from 6 to 8 seconds at an interval of 2, and also the PTO damping coefficients. You can see the syntax in the code snippets on the left-hand side, and also the circled text. MCR option 2 allows users to specify an an Excel file name that contains the set of wave statistical data in the WEC-Sim input file. You can see on line 11 on the right-hand side that the simu.mcr Excel file is set to wavestatistics.xlsx. So that is specifying which file WEC-Sim should look for. This option is generally useful for generating power matrices. In this example, we show a snippet on the left-hand side of the wave periods in row 1 and the wave heights in column A, and then the values in the matrix, it's a binary, so a 0, 1 specifies whether the C state should be executed or not. In the middle, you can also see the MCR structure that's generated as a result of the values specified in the Excel file, which overwrite what's defined in the input file on the right-hand side. And option 3 allows users to provide an MCR case file as a .mat file that directly specifies the C states that users would like to run, or the cases that users would like to run. This is executed by specifying in the WEC-Sim input file simu.mcr mat file is equal to a file name. As you can see on the left-hand side, we have an example of that .mat file that is specified on line 11, and in the middle, the MCR structure that is defined in that .mat file. So it's mcr.header and mcr.cases. A note here is that option 3 overwrites both options 1 and 2. So even if you have a range of periods and wave heights specified in your input file, it will be overwritten by option 3. In addition to running batch cases, WEC-Sim MCR also executes user-defined function MCR, which is a script that allows users to develop custom post-processing scripts. It can be used to analyze simulation results and generate plots automatically. It can save selected data from each simulation to a different file name. This avoids overwriting the output .mat file under the output folder, and it minimizes the size of the output data for MCR cases. So we highlight selected data here, meaning you're not necessarily wanting to save the entire output data structure. And an important note here is that the indexing variable for each of the MCR cases is IMCR. IMCR is going to be the current index of the case being run. On the bottom left, you can see 2 example power matrices that were generated from WEC-Sim MCR using the same C states, but 2 different damping matrices. And on the right-hand side, you can see a snippet of the script that was used to generate those plots. Just highlighting that all of these cases are available on the WEC-Sim applications repository, so you're able to execute these cases as is and generate these plots. WEC-Sim also allows users to run cases in parallel using the WEC-Sim PCT command in the command window. However, this feature requires the MATLAB Parallel Computing toolbox. The advantages is that it allows users to run batch runs in parallel instead of running them in series like WEC-Sim MCR does. This speeds up large simulations, and similar to MCR, this PCT feature allows users to execute batch runs with options 1 to 3. Some important notes is that WEC-Sim PCT is not compatible with user-defined functions MCR. You must use user-defined functions.m instead. And for PCT runs, the H5 hydro data must be reloaded regardless of the setting for simu.reload H5 data in the WEC-Sim input file. This is just due to the parallel nature of the run. Thank you for watching the WEC-Sim training course. For more information, please visit the WEC-Sim website using the link provided. And if you have any questions about this presentation or really anything WEC-Sim related, please reach out to any of the WEC-Sim developers using the GitHub issues page. Thank you very much. Bye.